So now that we have discussed about the different types of numbers, we also know what are prime numbers and composite numbers. So what are prime numbers? Prime numbers are the numbers which do not have the factors. The only factors for prime numbers are 1 and itself. Say for example, I take the number 3. Then I cannot have different factors for 3 except I can write this as 3 times of 1. So this is an example of a prime number. But say for example, when I take the number 6, this is not a prime number because the number 6 can be expressed as product of factors. Like you have 6 which can be expressed as 2 times of 3, but 7 which cannot be expressed except with 1 and itself. So the numbers which can be expressed as product of different numbers other than 1 and itself are said to be the composite numbers. And the numbers which cannot be expressed as the product of 2 different or more than 2 different numbers except 1 and itself are said to be the prime numbers. So in case of this, 7 which can be expressed as product of 1 and itself is strictly by the definition a prime number. But same case when I take with 6 which can be expressed as product of 2 different numbers which are not 1 and itself, then at least if you can identify one factor which can satisfy the product which doesn't consist of 1 and itself are said to be the composite numbers. So this is an example of a composite number and this is an example of a prime number. So there are different cases through which we identify the composite and prime numbers. So what about 91? 91, is it an even or an odd number? Is how I had to check. 13 times 7 is 91. So definitely this should be a composite number. It cannot be a prime number because the factors of 91 are 13 and 7. So it is an example of a composite number. So with this discussion of prime and composite numbers, which we already discussed in the lower classes, now comes the most important theorem in mathematics connecting the prime and composite numbers, called the fundamental theorem of arithmetic. So let's see what's the definition or what's the statement which makes the theorem. So fundamental theorem of arithmetic states that any number any integer, because I start with integer, so any integer can be expressed as product of prime factors. So this is the theorem which has come after studying the prime and composite numbers. So let's complete the statements and discuss on how this statement supports for different numbers. So any integer can be expressed as product of prime factors and the product is unique in whatever order the prime factors are considered. So this is how the fundamental theorem of arithmetic has been stated. So let's reconsider the case. It says that the definition of the statement of fundamental theorem of arithmetic says that any integer which we consider can be expressed as product of prime factors. That means any number you take in it as which is an integer that can immediately be expressed as product of prime factors, any number. And the product is always unique. You cannot get two different factors for each of the cases. It would be different. Then in this case, the product is always unique in whatever order the prime factors are considered. So let's support this statement with different examples and see whether the statement is true or false. So to start with, let me start with an example. 24. As I know that 24 is clearly an integer, then I see that this can be expressed as different product of different factors. So let's try to find all the possible factors using the LCM method. So I have this 24, then starting with 2. Therefore, 24 can be written as 2 times of 2 times of 2 times of 3, which in turn gives me 2 cubed times of 3. So therefore, I can write 24 as 2 cubed times of 3, where each of the factor is identified to be a prime number. 2 and 3 are prime numbers. So my statement which says that any integer can be expressed as product of prime factors stands true. I have taken the integer 24, and when I express it as a product of factors, I get this to be all primes. Is a very important statement which has been derived from fundamental theorem of arithmetic. So similarly, the statement also extends itself, stating that the product is unique. Unique means one and only one. So this product cannot be changed. If whatever order the prime factors are considered, this cannot be changed into different forms. Now whatever factors I got here must be fixed and unique. This is the only one possibility for expressing 24 as product of different factors. You cannot get any other form where that can also state that the product of those factors also give me 24. It is not possible. It is a very important research which has been made in prime and composite concepts. So therefore, the fundamental theorem of arithmetic finally makes us understand that you take any number which is an integer can be expressed as product of different prime factors and the product is unique. To support with one more example. Let me take 54. So I have the number 54, which I can write it as so I can express this as 54, which can clearly be expressed as 3 times of 3 times of 3 multiplied with 2. So 54 multiplied with each of 2 and 3 clearly makes me understand that all of the numbers which are considered in the product are primes. 2 and 3 are primes. And the product is unique. You cannot change this into any other form to multiply and get 54 in whatever order the prime factors are considered. Therefore, these two examples finally conclude that any integer taken into consideration can be expressed as product of prime factors and the product is unique. So some mathematicians modify this term integer with a composite number because the product of factors is generally the very much connected definition of a composite number. Therefore, an integer here is more replaced with a composite number. Therefore, my statement can be reread as any composite number can be expressed as product of prime factors and the product is unique in whatever order the prime factors are considered. So 24 is a composite number which can be expressed as product of these 2 cubed times 3. 54 is a composite number which can be expressed as 2 times of 3 cubed is how I understand the concept. This can also be applied for a non-composite number. Say I take the prime number 13 is again expressed as 13 times of 1 expressed as product of primes 1 and itself. So mode modified statement replaces integer with composite number.